friends, look at this question and try to solve it by yourself without doing any calculation. Okay, let's start how to solve it. First, I will break this question in two ways. We think over the question in a qualitative way, then we try to solve it by written. We call it quantitative way. Let's see here. First, read the question carefully. What the question is telling: you have a charge given here, and this charge is enclosed by a hemisphere which has radius r, and that hemisphere is covered by other side with a cone, right circular cone, which has a height of h and with the same radius r. Means now the moral of the question is the charge is completely covered by half of a sphere, a hemisphere, and rest half with a cone. Okay, now in the question, the value of the electric flux passing through the cone, the conical portion, is this. We have to find the value of n. That's the question. Clear? See, think about Gauss law. The question is easily solved by the help of Gauss law. Think about the Gauss law. What is Gauss law? What Gauss law tells us? Gauss law tells us that if a charge is enclosed inside a closed surface, the flux, electric flux through the closed surface is always charge divided by epsilon naught. I have taken four examples. See, this is one example. Here the same charge is completely enclosed. Electric flux Q by epsilon naught through the enclosed surface, the closed surface which is enclosing the charge. I have taken four examples here to teach you how Gauss law works, how Gauss law helps us to solve this question easily. Here the charge is enclosed by a spherical closed surface. The same charge is enclosed by a random closed surface, no specific shape and size. Same charge is enclosed by a closed surface which is like diamond shape, and here inside a cuboid or cube, the charge is enclosed by a cubical closed surface or cuboidal closed surface. Okay, according to Gauss law, the net flux, the net electric flux through all these four types of Gauss law, all these four types of closed surfaces is Q by epsilon naught. It's free from the design of the surface shape and sizes. Okay, not only this, for any type of structure which is closing the charge, which is enclosing the charge completely, total closed surface, the flux will be Q by epsilon naught. Remember this. This is the concept of Gauss law to solve such type of questions. Now, look at the question. This charge is enclosed by a spherical Gaussian surface. So what will be flux through this spherical Gaussian surface? This. And if I will have this Gaussian surface, I will half of this Gaussian surface, then half of this sphere will be a hemisphere, and that hemisphere has half of this electric flux, and that's it here. Means if a charge is enclosed by a spherical Gaussian surface, then to find the value of electric flux through hemispherical Gaussian surface, half of this sphere is a hemisphere, and the flux through hemispherical Gaussian, okay, see, flux through the half of this sphere, that is hemisphere, means electric flux through the hemisphere Gaussian surface is this flux through the hemispherical Gaussian surface which is enclosing this point charge is half of the net flux, Q by epsilon naught. So Q by 2 epsilon naught, because this hemisphere is half of the total spherical Gaussian surface which is enclosing the point charge, Q by 2 epsilon naught. And see, this is the key point of this question, how to solve it. This passes through the half of the Gaussian surface, which is hemisphere here. Now the rest half is a sphere here. Remove this sphere and attach a cone here. Understood? Then the rest of the half Gaussian surface, the rest of the half electric flux is passing through this conical Gaussian surface. Earlier, a sphere was covering the entire charge. Here, half of the sphere means hemisphere and rest half is cone. Means the rest half of the Gaussian electrical flux is passing through this conical Gaussian surface, Q by 2 epsilon. And means in this question, the electric flux through this conical Gaussian surface is Q by 2 epsilon, because it is taking the place of the half of the sphere. Now the value of an electric flux through the conical Gaussian surface in the question is this. So this and this are equal in calculation, so I have equated them, and after equating I get the value of n equals to 3, because q cancel, epsilon cancel, n equals to 3. Means the question is solved. Let's see what is the key point in the question. You have to remember always, whenever you try to solve Gaussian surface or Gauss law questions or problems based over Gauss law, you have to remember one thing. This is the net flux through the entire closed surface, closed Gaussian surface that is enclosing the charge, whatever be its shape and size. And now half hemisphere, other half is the cone, so half goes to hemisphere, other half goes to cone. In either shape like this, half here cone, half here cone. So this cone also contains Q by 2 epsilon naught, and this cone also contains Q by 2 epsilon naught. Means you have to think that, and by this analysis I think it is clear. You can easily apply Gauss law to any such problem and solve it. Now I have a question for you. Here this is the pointed part and this is very flat part. Flat means the arc of a spherical part where the electric field is high. Flux is same throughout the entire closed surface, that is this net flux. Where is the field high? Where the electric field is high? Either here or here, and why? Comment me. And if you like this question, then like and subscribe my channel. Thanks for watching.